PCI, Peripheral Component Interconnect Express. Bottlenecking happens when the bandwidth available on your PCIe slot is insufficient to keep up with the demands of the device connected to it. Here's what you need to know. What causes a PCIe bottleneck? Lane mismatch is the most common culprit. For example, running a PCIe 4.0 to X16 GPU and a PCIe 3.0 X8 slot cuts available bandwidth roughly in half. While this rarely causes major issues for most GPUs today, it can become a limiting factor at very high resolutions or with bandwidth-hungry workloads. Generation mismatch also matters. Each PCIe generation roughly doubles the bandwidth of the previous one. When does it actually matter? For gaming GPUs, a PCIe 3.12 PCIe slot versus a 4.00 X16 slot typically results in less than 1 to 3% performance difference in most games. The GPU's compute power is usually the real bottleneck long before PCIe bandwidth is. For NVMe SSDs, the story is different. A PCIe 4.0 or 5.0 NVMe drive in a PCIe 3.0 slot will be noticeably limited in sequential read-write speeds. For professional workloads like video editing, ML training, or heavy data transfer, PCIe bandwidth matters much more, and a bottleneck can have real impact. How to check? If you're bottlenecked, use GPSWZ or HWINFO64 to see which slot your GPU is running in and at what link, speed, width. Look for X8 or X4 in the current link width when you expect X16. That's a red flag. Compare benchmark results against expected performance for your card. How to avoid it? Match your GPU to a full X16 slot running at the latest PCIe generation your CPU TARC motherboard supports. Check your motherboard manual. Many boards share lanes between slots, meaning two populated slots may each drop to X8. If using multiple devices, plan your lane allocation carefully. In short, PCIe bottlenecking is real but often overstated for gaming. It matters most in professional, multi-device, or high-throughput storage scenarios.